Usually when you're handed the keys to a new vehicle, you just get in, turn the ignition, and, well, you steer. You don't really need to understand how the fuel injection system works.
Right. Or the specific calibration of the transmission.
Exactly. The mechanics are hidden away so you can just focus on the road.
Which is, how most users interact with technology. I mean, they
Always.
just want the application to open when they click the icon.
But stepping into the world of enterprise IT, and specifically preparing for the CCA-V exam, that is an entirely different situation.
Oh, absolutely. It's a whole other ballgame.
You are essentially being handed the keys to a massive, incredibly complex digital machine that powers an entire enterprise. And you've got 90 minutes.
Yep, 90 minutes to prove you know what you're doing.
Right. You're facing 60 to 65 complex, scenario-based questions standing between you and that certification. We aren't just going to memorize the owner's manual today. We're going to put you right in the driver's seat.
Because to pass this exam, and more importantly, to actually manage these environments, you have to understand exactly how every single gear turns.
And the margin for error is tight, isn't it?
It is. The passing score is 65%, and the exam is delivered in English. But, I mean, the margin for error in the real world is much tighter than just a test score.
That's our mission for you on this deep dive. We are unlocking the technical concepts and the strict assessment criteria for the CCA-V exam.
Sounds like a solid plan.
We are going to read the full text of 10 actual practice questions from our source material. We will break down every single option A, B, C, and D and analyze the underlying problem-solving logic.
Which is crucial. Because figuring out why the wrong answers are wrong is, well, it's just as critical as finding the right one.
Right. It builds that intuition.
Exactly. It builds the intuition you need. If we start at the foundation, before looking at the sprawling back-end infrastructure, an administrator first has to control user access and system resources on a very granular level.
So let's start right there at the machine level with question 1.
Let's hear it.
Here is the full text. A Citrix Administrator is deploying Workspace Environment Management to improve user density and performance on multi-session OS machines. Which 2 optimization features can the administrator enable within this tool to prevent individual applications from monopolizing system resources? Choose 2.
Okay, gotcha.
And her 4 options are A, network bandwidth throttling, B, CPU management, C, storage input-output prioritization, D, memory management.
So the scenario specifically targets multi-session OS machines. You have a dozen, maybe 2 dozen users sharing the exact same underlying hardware.
Right. They're all piled onto one server.
Exactly. The correct answers here are B, CPU management, and D, memory management. CPU management stops a single, badly behaved process from hogging processor time.
Like a user running a massive, unoptimized Excel macro.
Yeah, exactly that. It dynamically throttles that specific process down. And memory management does the same for RAM, forcing idle applications to release memory back to the system so active users stay responsive.
I'm looking at option C, the storage input-output prioritization. If an application is thrashing the disk with read and write requests, that monopolizes resources too, doesn't it?
It does.
So why wouldn't that be a correct answer? I mean, it causes a bottleneck.
It definitely causes a bottleneck, but look at the specific phrasing of the prompt. Workspace Environment Management, or WEM, is fundamentally designed to optimize the compute layer like the user's immediate workspace.
Ah, okay. The compute layer.
Right. While storage I/O is a valid concern, the specific WEM optimization features designed to clamp down on application monopolization in real time are focused heavily on compute and RAM.
It's almost like WEM is acting as a bouncer at a buffet.
A bouncer at a buffet, I like that.
Yeah, you've got all these guests, and CPU and memory are, the prime rib and lobster. The bouncer steps in to ensure no single guest hoards all the expensive food, making sure everyone gets a plate.
That is a perfect analogy.
And that logic helps eliminate option A, network bandwidth throttling as well. Throttling the network doesn't solve the immediate local problem of an app eating up the motherboard's resources.
Exactly. You have to match the tool to the specific bottleneck the scenario presents.
So if we are managing the machine's resources, we also have to manage the access of the IT staff interacting with those machines. Let's look at question 2.
All right, what do we have?
A Citrix administrator needs to grant a helpdesk team the ability to shadow user sessions and reset virtual machines using Citrix Director. However, the team must not be allowed to publish new applications or create machine catalogs, which built-in delegated administration roles should be assigned.
And the options?
The options are A, full administrator, B, machine catalog administrator, C, helpdesk administrator, D. Host Administrator.
So Citrix Director operates on a strict principle of least privilege. The built-in role designed for this is C. Helpdesk Administrator.
Makes sense given the name.
Yeah, it is meticulously scoped for frontline support staff. It grants the ability to shadow a struggling user and reset frozen VMs, but it hard stops them from altering the broader environment.
The exam designers are setting a pretty obvious logical trap here with the other options, right?
Oh, absolutely.
The prompt explicitly states the team must not be allowed to publish apps or create catalogs. Option A, full administrator, obviously violates that immediately.
Right, you'd never give a frontline team full admin rights if you can avoid it.
But option B is literally called machine catalog administrator, which is the exact power the prompt says they shouldn't have.
Yeah, it tests your ability to isolate the negative constraints in the prompt. You have to read what they are explicitly forbidden to do.
Now, controlling who can reset a frozen VM is important, but what happens if the core system that routes those users collapses?
Then nobody's getting any work done.
Exactly. Controlling access is pointless if the backbone is broken. Let's examine the infrastructure with question 3.
Lay it on me.
A Citrix administrator is designing a highly available Citrix virtual apps and desktops environment for a large enterprise. Which two core infrastructure components require a highly available SQL Server database setup to ensure continuous operation and management capabilities? Choose two.
Okay.
Options are A. Citrix Storefront, B. Citrix Delivery Controller, C. Citrix Provisioning Services, D. Citrix Workspace App.
The correct answers here are B, Citrix Delivery Controller, and C, Citrix Provisioning Services, which is commonly known as PVS.
So the controller and PVS.
Right. The Delivery Controller is brokering the complex distribution of virtual apps and desktops. And PBS handles diskless machine provisioning, streaming operating systems over the network.
And they both need that SQL database.
Heavily. Both of these components rely heavily on a highly available SQL Server database. The database stores the site configuration, logging, and the real-time state of every single session and virtual disk lock.
Let me make sure I'm mapping this out correctly. If the delivery controller and PVS are the brains of the operation, making the routing and streaming decisions, then the SQL database is essentially their memory.
That is a very solid way to conceptualize it.
Because without memory, the brains can't do much.
Exactly. If the database goes offline, the delivery controller can't look up who is allowed to connect to what, and PVS loses track of which target devices are online and which virtual disks are locked. The brains fly blind without that memory.
Which makes eliminating option A, Storefront, and option D, the Workspace app, fairly straightforward, right?
Yeah, pretty much.
I mean, those are user-facing access points. They are the doors to the building. They don't require that constant foundational SQL backend connection just to keep the lights on in the same way the core controllers do.
They interact with the controllers, sure, but they aren't the components maintaining the state of the entire site in SQL.
Okay, so if PVS is streaming these machines, they eventually have to register with the delivery controller to actually be useful.
Yep, registration is key.
And the exam tests this specific vulnerability. Let's look at question 7.
So go for it.
Multiple newly provisioned virtual delivery agents are failing to register with the delivery controller. Time synchronization is verified to be accurate across the entire environment, and firewall rules are correct. What is the next most probable conceptual cause to investigate?
Good question. What are the choices?
Options are A, the license server is out of available concurrent licenses. B, the hypervisor connection is currently in maintenance mode. C, the application load evaluator is at maximum capacity. D, the service principal names are duplicated or missing.
So this scenario is all about component trust. The answer is D. The service principal names, or SPNs, are duplicated or missing.
SPNs.
Right. SPNs are fundamental identifiers for network services within Active Directory. When a newly provisioned virtual delivery agent, or VDA, tries to register, it attempts to authenticate securely with the delivery controller.
And if those SPNs are messed up?
If the SPNs are corrupted, duplicated, or missing, Kerbero's authentication fails. The controller simply will not talk to a VDA. It cannot securely identify.
You know, the prompt is actually giving us massive clues to eliminate the other choices if we just follow the chronological sequence of how a machine boots and registers.
Exactly. Walk me through it.
Well, it says time sync and firewalls are good. It also specifies this is a registration issue for newly provisioned VDAs. So if we look at option A, a license server issue, the VDAs would likely still register, wouldn't they?
Yeah, they'd register, but users would get an error when launching an app later on.
Right. And regarding option B, if the hypervisor was in maintenance mode, power management would fail.
Yep, the machines wouldn't even provision or boot up properly in the first place, let alone reach the registration phase.
And option C, the application load evaluator, that only matters after a machine is registered and is actively trying to take on user sessions. Spot on. So logically, SPN authentication is the only remaining barrier in that specific provisioning to registration pipeline. You have to step through the architecture chronologically. Boot, network, authenticate, register, broker.
So we have a secured backend and authenticated machines. But all of that highly available infrastructure is entirely at the mercy of the real world, specifically the network connection.
Oh, the network is always the wild card.
Always. The CCA-V heavily tests your ability to handle dropped connections. Let's look at question 5.
Right.
A company is designing a Citrix DaaS resource location. They want to ensure that user connections to existing sessions remain active and new connections can be established even if the connection to Citrix Cloud is temporarily lost. Which feature should the Citrix Administrator configure?
And the options.
Options are A, localhost cache on the cloud connectors, B, a secondary resource location, C, an additional storefront server, D, the identity provider token lifetime.
The correct answer here is A, localhost cache on the cloud connectors. It is a critical survival mechanism.
How does it work? Well, localhost cache stores a subset of the site database locally on your cloud connectors using SQL Express. So if your internet drops and you sever the connection to the Citrix Cloud control plane, the localhost cache service takes over brokering.
So it just seamlessly steps in.
Pretty much. Active sessions stay alive, and new users can establish connections based on that cached data.
It functions almost exactly like a hospital's backup generator.
Another great analogy.
Right. The main power grid, the Citrix Cloud connection, goes down in a blackout. Instantly, the localhost cache generator kicks in locally. The lights might flicker for a second, but the surgeries keep going.
And new patients can still be admitted.
Exactly, until the main grid comes back online and everything syncs back up.
It maintains operational continuity.
Looking at the other options, B, C, and D do not solve the specific problem of losing connection to the control plane for an existing resource location.
No, they don't.
Throwing an extra storefront server at the problem won't magically broker a connection when the brain in the cloud is unreachable.
Exactly. But what happens when the connection doesn't drop completely, but is just agonizingly slow? High latency environments require a completely different approach.
Which brings us perfectly to question 6. An administrator is configuring Citrix policies for a branch office with severe bandwidth constraints and high latency. Which 2 policy settings should the administrator configure to significantly reduce the bandwidth consumed by user sessions? Choose 2.
All right, what are our choices?
Options are A, limit maximum frames per second, B, enable universal print server, C, increase audio quality to high definition, D, restrict client drive mapping.
The answers here are A, limit maximum frames per second, and D, restrict client drive mapping.
Why those 2 specifically?
Well, to understand why, you have to look at how the HTX protocol handles data. Graphical updates consume the lion's share of bandwidth. By capping the frames per second, you're forcing the protocol to prioritize input responsiveness over visual fluidity.
So it might look a bit choppy, but the user's keystrokes will actually register in real time.
Exactly. It's about keeping the session usable.
And restricting client drive mapping stops the system from running background SMB traffic over the virtual channel, like transferring files between the user's local laptop drive and the remote server.
Right, which eats up bandwidth fast.
I have to point out option C here, though. Increasing audio quality to high definition would achieve the exact opposite of our goal.
Oh, it would be a disaster.
It would just flood the pipe and destroy whatever tiny trickle of bandwidth you have left.
Yeah, sometimes the exam includes an option so counterproductive it serves as a baseline check of your understanding. High-def audio on a constrained branch office link would render the session completely unusable.
Let's finish up this network survival section with question 8.
Let's do it.
A Citrix administrator is configuring external access policies for a remote workforce. Which 2 features work together to ensure that a user's screen remains visible but frozen during a brief network interruption and then automatically reconnects when the network is restored? Choose 2.
Okay, what are the options?
Options are A, session reliability, B, adaptive transport, C, auto client reconnect, D, frame hawk virtual channel.
The correct answers are A, session reliability, and C, auto client reconnect. This is a crucial pairing for user experience.
How so?
When the network blips, Session reliability intercepts the disruption. Instead of throwing a generic network error and instantly kicking the user out, which usually results in a panic call to the help desk, it holds the visual state of the application.
So the screen freezes and a timer starts.
Yes. Meanwhile, AutoClient Reconnect works in the background to seamlessly negotiate and restore the session the second the packet flow returns.
I see adaptive transport sitting there as option B. Since EDT, the protocol behind adaptive transport, is specifically designed to handle bad networks with packet loss, why wouldn't that be one of the answers?
It's a fair question, but it's because of the specific behavior requested in the prompt. Adaptive transport uses UDP to gracefully handle packet loss and keep data moving, but it is an underlying transport protocol.
So it doesn't handle the UI side of things.
Right. It doesn't govern the user interface behavior of freezing the screen and presenting a reconnection timer. Adaptive transport is the road the data travels on. Session reliability is the visual safety net for the user.
Okay, that makes a lot of sense. So we've secured the backend and we've built policies to survive network outages and latency.
Which brings us to the user.
Exactly. The final piece of the puzzle is optimizing the user's daily experience. Let's look at question 4.
What's the scenario?
Users are complaining about slow log-on and log-off times. The administrator discovers that large, non-essential user-generated video files are being synchronized to the central profile store during log-off. How can the administrator prevent these specific large files from extending the log-off duration without deleting the user's files from their local sessions?
And the options are?
Options are A, enable active write-back, B, configure profile streaming, C, delete local cached profiles on logoff, D, implement folder exclusion policies. Honestly, if I'm looking at this as a frustrated admin, option C, deleting the local cached profiles on logoff, seems like the fastest way to kill the problem. The files are gone, the sync is empty, logoff is instant.
You could do that, but look at the strict constraints of the prompt. It says you must fix the duration without deleting the user's files from their local sessions.
Yeah, there's the catch.
Yeah, if you choose C, you fix the metric on your dashboard, but your users are going to be screaming tomorrow morning when all their local video drafts are wiped out.
Right. It's an IT solution that ruins the user experience.
The correct answer is D, implement folder exclusion policies. Profile management allows you to be surgical.
Surgical how?
By configuring a folder exclusion, you are instructing the system to sync their registry settings, their small documents, their app data, but completely ignore the specific folder path containing those massive video files.
So the sync finishes in seconds instead of minutes.
Exactly, speeding up the log-off, but the files safely remain on the local machine for the next session.
Let's talk about preserving that specific user state with question 9.
Go ahead.
When updating a machine creation services catalog with a new master image, an administrator wants to ensure that all personal user settings and locally installed user applications are preserved exactly as the user left them after the machine's reboot. Which catalog type must be in use to support this requirement?
And the catalog options.
Options are A, dedicated single-session OS machines, B, pooled random multi-session OS machines, C, fast clone provisioning machines, D, stateless virtual desktop machines.
The defining concept here is persistence. The only logical answer is A, dedicated single-session OS machines.
Because they belong to one person.
Yes. The entire architectural purpose of a dedicated, statically assigned machine is that it belongs to one specific user, and it writes changes to a persistent disk. Their custom background, their specific application settings, and their files remain exactly as they were, even after the administrator updates the base master image and reboots the machine.
Which is the polar opposite of options B and D.
Oh, completely.
Pooled random and stateless machines are specifically engineered to act like an etch-a-sketch. The user logs off, the machine reboots, and it completely wipes out all local changes, returning to a pristine, generic state.
Right. They're designed to destroy local changes, so they are entirely wrong for a scenario demanding preservation. Knowing what a technology is designed to discard is just as important as knowing what it's designed to preserve.
All right, our final question, question 10, focuses on the very beginning of the user's day.
The morning rush.
Yep. Users report that launching their first application of the day takes too long. The administrator wants to start the user session in the background as soon as the user authenticates to Storefront before they even click an application icon. Which feature should the administrator enable?
Let's hear the choices.
Options are A, session reliability, B, session pre-launch, C, application lingering, D, fast logon.
The answer is B, session pre-launch. The heavy lifting of a Citrix session, loading the profile, applying group policies, mapping network drives, It all takes time.
And pre-launch fixes that.
Pre-launch shifts that burden.
Mm-hmm.
Instead of waiting for the user to click an icon, it does all that heavy lifting invisibly in the background the exact moment the user authenticates to the storefront portal. By the time they actually move their mouse and click the app icon, the session is already fully constructed. The application appears almost instantaneously.
Can we clarify the strict difference between session pre-launch, which is option B, and application lingering, which is option C?
Sure.
Because in practice, they sound like they achieve a very similar goal of keeping a session ready.
It comes down to the timeline of the user's behavior. Pre-launch is anticipatory. It happens before the user clicks anything, usually at the start of the day.
And lingering.
Lingering, on the other hand, happens after the user's done working. If a user closes their last published application, lingering prevents the session from immediately logging off. It keeps the session alive in the background for a set duration.
Oh, I see.
That way, if they realize they forgot to send an email and click the app again 5 minutes later, it opens instantly without having to rebuild the session from scratch. Pre-launch is for the morning arrival. Lingering is for the coffee break.
One anticipates the arrival, the other delays the departure.
As we wrap up, there is a broader concept for you to consider. We've spent this deep dive looking at how an administrator manually configures these vital features, setting CPU limits, defining folder exclusions, turning on session pre-launch to save seconds of logon time.
Very hands-on stuff.
Right. But as these environments become increasingly driven by telemetry and automation, the role of the administrator will shift. Will you transition from being the mechanic who manually toggles these specific policies under the hood to becoming an air traffic controller?
An air traffic controller?
Yeah, overseeing automated self-healing systems that adjust these parameters on the fly based on real-time behavior.
Are you the one turning the wrench, or are you just watching the machine turn its own wrenches?
Exactly.
Either way, you still need to know how the gears work. Because when you're handed the keys to a digital machine that complex, you better know exactly what happens when you turn the ignition. Until next time, keep digging deeper.